Bismillahirrahmanirrahim. Previously, you know about J.J. Thomson's work, and he presented plum pudding theory of an atom. That atom consists of a positive portion and the negatively charged particles, which are said to be electron. They are embedded in it. Here I am giving you the example of GABA. This red portion consists of a positive particles, and these are the electrons which are embedded or they are stuck inside. This was the old concept of an atom according to J.J. Thomson. While you know the Rutherford said actually what happens, the positive particles are present within the nucleus. Say it's the hydrogen atom consists of one proton and one electron, and proton carries a positive charge. So I'm showing here a positive sign. It's a proton present within the nucleus. And according to Rutherfords, the electrons, which are the negatively charged particles, they are moving around the nucleus in a specific way or orbit. This was the Rutherford's model of an atom. Now see what are the defects in Rutherford atomic model. There are two main defects. What is the first defect? According to Rutherford, when an electron is moving around the nucleus, this electron possesses certain energy. And you know what is energy? What is energy? Capacity of a system to do work is called energy. It means anything which works, it has an energy, and its capacity which is used to do work, that is said to be energy. Now this electron, it possesses certain energy, and when it possesses certain energy, it means it will definitely move within the orbit. Now what happens, this electron, when it is moving around the nucleus in the orbit, it radiates energy continuously. Continuously, the energy is being emitted by the electron. When the energy is being emitted by the electron, what will happen? Ultimately, this electron will possess no more energy. It means the energy will be zero. When energy will be zero, what will happen? This electron will fall into the nucleus. According to Rutherford, when this electron falls into the nucleus, what will happen? Definitely, conclusion is that atom will collapse. The death of atom will occur. While it doesn't happen, again, I can clear you an example. This thing with an example. Suppose that this is an ox. Okay, the ox is moving around the well for irrigation purpose. Now this ox is moving around the well continuously. Why? Because it has energy, it has capacity to do work. A time will come, a time will come when it will get tired, it will have no more energy, and it will fall definitely near about the near around the well. Okay. Now this was the defect there, because this doesn't happen. Electron doesn't fall into the nucleus. This was the first defect in Rutherford's atomic model. The second defect of Rutherford's atomic model is According to Rutherford, when electron is moving around the nucleus and is continuously emitting energy, it should give lines, it should give a continuous spectrum, a continuous spectrum. Okay. Best example of continuous spectrum is rainbow. After rain, when the rain stops, you see rainbow in the sky. It consists of several colors, and all these colors they merge into one another. Like suppose this is a violet color, I'm just showing you. Then blue color, similarly yellow, green color, similarly yellow, red color, and somewhere here blue color, etc. Now these colors they merge into each other in such a way that we don't know from where the one color is starting and from at which point the color is ending. This is blue. See, this is violet color. Yellow color here is missing. Red color. Okay, etc. According to Rutherford, when electron is continuously emitting energy, it should give us continuous spectrum just like the rainbow. That color should merge into each other. Why this does not happen? Because in this case, in case of an atom, we don't get a continuous spectrum, we get a line spectrum. This line spectrum was shown and was presented by Bohr, which came after Rutherford, and he discarded the ideas of Rutherford that atom will give us a continuous spectrum. Now, what is a line spectrum, or how do we get line? According to Bohr, what he said that electron is present around the nucleus in specific orbit, in different orbits. This is the first orbit, this is the second orbit, similarly this is the third orbit, and say it is the fourth orbit, fifth orbit, and then the sixth orbit, and so on. So according to Bohr, the electrons are present around the nucleus in specific orbit. Okay, see, this is an electron. It's an example of a hydrogen atom. Hydrogen atom. Now, how do we get line spectrum? According to Bohr, what happens? He say when electron jumps from one orbit to another orbit, it absorbs energy. But when uh, it comes or it jumps from an orbit of higher energy level to an orbit of lower energy level, from upper orbit to lower orbit, it emits energy in the form of lines. So he said that when an electron jumps from sixth orbit to second orbit, it radiates energy, and it radiates energy in the form of line, and that line consists of a purple line. It gives a purple line. This is the case of hydrogen atom, and this line occurs at 410 nanometer. Okay, now same electron of hydrogen atom, when it jumps from fifth orbit to sixth orbit, again it radiates energy, or we say it emits energy in the form of wave, and that radiation, that wave, it stands at 430 nanometer, and it gives us blue violet color. Okay, blue and violet color. Blue violet color, this we get at 450 nanometer. N means nano, M means meter, nanometer. Now what happens that when electron jumps from fourth orbit to second orbit, again it emits energy, and the energy and the radiation fall at a distance of 4. It has a wave of 486 nanometer, and the color is blue green. Blue color and a green color, and this happens at 486 nanometer. And when electron jumps from uh, third orbit to second orbit, then it emits radiation, and this radiation is at a longer wavelength, and this radiation consists of red color, and the wavelength is 656 nanometer. Now what is wavelength? This is a wave. Similarly, this is also a wave. This is also a wave. The distance between these two crests, ये जो पहाड़ बने हुए हैं, इनके दरमियान जो distance है, it is called as wavelength. Okay? Or between two troughs. These are the two troughs. The distance between these two troughs is again said to be as wavelength, shown by this sign. उल्टा y लिख दे तो ये lambda कहलाता है. In case of line spectrum, when we move from left to right, what happens? The wavelength, it increases in this order. It means red color जो है, it possesses more wavelength as compared to violet. This is the violet color, it possesses lesser wavelength. Okay, that's why you have seen the line spectrum. In case of line spectrum, the red line at a distance 656 nanometer wavelength. It means wavelength is very large as compared to the purple line, and the wavelength of purple line is 410 nanometer. Why is this so? Because the formula is E is inversely proportional to 1 over lambda. It means energy is inversely proportional to wavelength. Greater is the wavelength, lesser will be the energy. and smaller is the wavelength. 4 nanometer is very short wavelength. Smaller is the wavelength, higher will be the energy. इसीलिए हमारे पास जो अल्ट्रा वायलेट रेज होती हैं वो इसी जगह फॉल करती हैं. Okay, so there are two defects. The first was that electron radiates energy and it will ultimately fall into the nucleus, while this does not happen. Second is that electron will give you a continuous spectrum just like a rainbow, while it was found that and in case of an atom no continuous spectrum is seen. It gives us a line spectrum. And here I have shown you the example of hydrogen atom, line spectrum of hydrogen atom, that what happens when the electron of hydrogen atom jumps from sixth orbit, fifth orbit, from fourth orbit, from third orbit to second orbit. It radiates energy at different wavelengths. These were the two defects. Okay, and they were solved by Bohr, and later on you will study inshallah Bohr's atomic model. Thank you.